Hello everyone, thanks for watching this video. So in this video, today we are going to understand the basic architecture of microservices, and we are going to understand the various aspects of the microservice and various API that we are going to use into the microservice and the various new concept also. Okay, so this video is only talking about the theory part. We are covering the coding part once we completed the tutorial of Spring Boot, since we are going to achieve the microservice using Spring Boot, and a Spring Boot video is so. Following with that, we are not going to do anything about hands-on here. We are going to understand all the concept in very high level and the related API that we are going to use in terms to achieve the microservice architecture. Microservice basically called as a microservice as well as the microservice architecture also. Okay, yes. So basic agenda of this video is we are going to cover what is the microservices and how it is different from our regular architecture, that is called monolithic architecture, and what are the prerequisites that we have to do to achieve the microservice, and obviously what are the advantages and disadvantages of the microservices. Following with that, we are going to understand the various terminology of the microservice, something called configuration management, naming server, load balancing, API gateway, service unique identification, distributed tracing, and fault tolerance. Okay, so these are all the basic word of the microservice. However, this is already we are using into the monolithic also, but we are going to elaborate more into the microservice part. Okay, good. So as we understand that what exactly is the microservices. See, microservices is basically will help you to deploy or run your application independently. Okay, suppose that if you are coming to your monolithic application, you have one application called, it has some three operation: add, update, and delete something. Okay, and you are going to deploy this service into the server. So what will happen is, suppose that your add service is getting failed due to some exception or some server exception or some downtime. Okay, so your update and delete will also got impact, and user can't able to do any operation among add, update, and delete. Okay, so user has to wait until your add operation becomes up or any of the failure thing got restored. So till that user has to wait. Okay, so that issue basically got covered into the microservices, and microservice architecture is telling that let's not build all the services into the one API. Let's have the three API called three services. Means your add is a separate services, update is also separate services, as well as delete is the separate services. Where add have the separate service called separate DAO, separate database, and separate server deployment, whereas the update also having the separate API, separate services, and separate DAO, separate DB, and the separate deployment server as well as the pipeline. Same as for delete also. Okay, so you have three services, three API becomes the three services into your microservices. First thing, and second thing is that each and every service will have more than one instance. One instance means, suppose that your add server is running on port called 800. Okay, the same service can also run in 8001, 8002. So one service, see, first we have API becomes service into the microservice architecture, and all the service have the many instance. Okay, so suppose that your add service microservice got down for some reason, then your another instance which is running on the different port has to pick the request that is coming from the user. So there are very 99.9% chance that your application will never be down. Okay, since for your each and every services having n number of or more than one instance. Okay, So that is basically all about the microservice architecture. Okay, we will got to know more about upcoming slides. Okay, now how it is different from the our monolithic architecture. As I already told you, monolithic architecture is tightly coupled with the each and every services, whereas our microservice is the loosely coupled. Since this is the loosely coupled, so we have to maintain independently in very flexible way. The reason is, earlier you have add, update, delete into the one application, okay, and you have some changes, some enhancement came into the delete, okay. So what we are going to do is we are changing the code for delete API, and we are going to deploy add, update along with the delete also into the server. That will go into the production, and that is running successful. Now in microservice architecture, if you have changes in delete operation, add and update service wouldn't will impact. They will run independent. Since they are running independently, and for each and every service we have the different pipeline created for deployment. So there is no chance that if I will deploy delete, add or update will impact. So these are all independent deployment happen. Okay. So this is how about the monolithic architecture on top of microservices. So what is the pre-request of the microservice architecture? See, when we are basically working on the microservice architecture, rather than on technology, we have to more focusing on the architecture. Architecture means your strong analysis. Suppose that there are two kinds of microservices. One kind that you have the monolithic application, and that you are going to convert into the microservice architecture. So in that way, converting is little easy. The reason is that we know the business, okay, and we know all the service call, we know all the DB schema, and we know all the dependent application or all the intermediate application. So in that way we have the application knowledge. So somehow we can able to manage the microservice architecture. Okay, these are the list of services we have, and these are the request and response we have. These are the all the database column getting populated with this service, and these are all the other downstream application that we know very well when we have monolithic application and we are trying to convert into the architecture. But just assume that you will be having a brand new application and that you wanted to convert into the microservice architecture. So when I am telling the brand new application, so when any of the application start, basically we don't have the much idea on the business part. When we start coding, start developing, there are many changes happen during then, and your actual requirement that came before development will got little change and become different. Okay, so in that this kinds of things we should not accept into the microservice architecture. We are very keen, we are very strong to do the analysis. Okay, the reason why I am trying to tell this one is, suppose that in nowadays we having the monolithic application, and we know if any defect came from the production, how difficult it is, right? Just assume that for one monolithic application we are following these many rules, okay, whereas if that case comes into the microservice architecture, you just have to assume that your microservice becomes the monolithic. How difficult for you to manage this one. So it is very difficult if your analysis is not strong, since for each service you have 3 instances, and you just assume that you are going to create the microservice architecture, and because of some reason you start calling one service each other, and it becomes the monolithic at the end. So you have to shut down your project, otherwise your maintenance will be very high. Okay, so this is first thing, strong analysis, how it matters. Strong documentation. A strong documentation means, see, we have n numbers of microservice. See, when I will tell you the microservice, you have to understand in monolithic way it's API call. Okay, so when we have n number of microservice, and for each microservice we have n number of instance, and for each instance we have different port number, right? So there should be some centralized place, wiki page or conference page, where we should have the strong documentation of each and every microservices, request, response, port number and URL, all those things. Otherwise, at the end, you got to know that okay, this port is taken by this service, and you also start using the same port. So for your two microservices, you are going to use the same port, and which is not correct. Okay. So these are all things you have to decouple with your strong documentation. Third thing is that you should have the strong team. A strong team as not as part of the technology, as part of the communication. Everything should be communicated very clearly. If you have many stakeholders, everyone should have the very strong communication within a team. So we can understand, okay, these are all things happening and these are the server got occupied and these are the server is free and all those things. Okay. Now infrastructure, since you are running a microservice, so your VM where we are going to deploy your code, it has some good amount of RAM. Okay, the reason is really a heavy load since one API having many instances. Okay, so if you are deploying 4 or 5 microservices into the one API or one server, make sure that that server is very highly capable to handle your all the microservice instance. This is all about your pre-request. Next is that what is the advantage of microservice. Till now you already understand that what is the microservices, what is the pre-request and all those things. Obviously we should have some in advantage also. Advantage means easy to enhance, means if you have some changes came into the delete part, you just have to touch the code along delete API only. Obviously flexible means if you want to change the delete code, there is no impact on add or update. So it's obviously flexible. Low impact on other service, that we already understand. Freedom to choose the technology. Being a theory part, this is very easy to say that freedom to choose the technology means you having 3 services or 3 business rule like add, update and delete. Add you want to develop into the Python, update you want to develop into the .NET, as well as delete you want to develop into the Java. That is totally acceptable into the microservice architecture, which is very good. But as soon as we say it's very good, but it is very costly also. The reason is your add coding happen on the Python, and you know Python having some different deployment pipeline, whereas for update, if you see, you have assumed that you will be having one technology called .NET, and we know for .NET we will be having different kinds of scripting to deploy, to do the build and all those things. And for Java, obviously different. So if you are going to use the 3 technology for 3 service independently, that is allowed, no issue. But only thing is that your cost becomes very high. Okay. That's the reason people are avoiding using the multiple technology for multiple services. However, it's allowed into the microservice architecture. Okay. CI/CD. As I already told you, you have add, update and delete, and we are going to create the different pipeline for each and every services that will help you to deploy independently into the different server. So that is totally correct. So next is software development approach. Nowadays we are frequently using the agile. Okay, in agile everything is fine, but if you see when the term come that dependency, means this API have some downstream dependency, this API or this service has some upstream dependency. Okay, so this kinds of dependency kinds of issue we are always facing into the agile, and we will be following various rule to overcome with this issue, means dependency issue. But since microservice is everything all together, is independent code, independent run, independent test, independent deployment, so there are very less chance that there's dependency what will come. So since dependency word is not coming frequently, so it's basically fit for the agile also. Okay. And next one is that what is the disadvantage of microservice architecture? Obviously, when something has the advantage, there must be a chance that there should be some disadvantage also. This one disadvantage is nothing much, but the thing is that your maintenance should be very high. As I already told you, one service having many instances and every instance running on the different server. So to maintain these are all port, process, server, and then your language also means Java, .NET, and Python. So this kinds of maintenance will little high from our general application. Okay. Testing effort is actually very high. The reason is if you are changing one module, you will test one module, but you never know that since this module have to get the data from somewhere, and somewhere this module also got interact with the other module, right? So in that way you have to do the each and every module testing. Sometimes people say that this is independent testing, but yeah, 80% this is correct, that independent testing for the each and every module, but in 20% you have to test your entire application also. So that required your automation effort rather than manual effort. And obviously you have to perform your performance testing frequently. The reason is if you are building any service with microservices, this is little slow. Reason is you have the many layer. Okay. So in that way, if your code also having some performance issue, then it impact your overall product performance issue. Another one is the documentation. Documentation, as we know nowadays, is very painful and developer don't want to do the documentation, and even though agile documentation is not permitted. But for microservice architecture, you should have a strict way to follow the documentation. Since this documentation is the way only you can identify your uniqueness of your each and every instance, microservice instance. So now coming to the microservice real things. Okay. So what is the configuration management in microservice architecture? Okay, so before microservice we have the monolithic, and there also we are doing many configuration, and there is not much difference from the monolithic to microservice on the configuration management. So first we will going to understand that what was the issue in the monolithic application, while for in terms of configuration management, then we will understand into the microservice architecture. Just assume that in monolithic application, you have application which is running perfectly. There is no issue, no defect, no production issue. Okay. Somehow your DB password got changed. You have Oracle DB and it got renewal, and somehow you have to change your DB password into the production. Okay. So to change the DB password, we know already this password is available in the properties file or some XML file or some configuration file. Okay. So just for changing the password, first you have to put the code into your local means Eclipse. Then you have to deploy into your dev environment. Then you have to deploy into the QA. Then you have to deploy into the UAT, and you have to do the testing for each and every deployment. And then that code has to promote into the production. To promote this code into the production, you also have to follow the many approvals from the higher business level people, and then you have to reach out your release management team to deploy these changes. And changes is nothing, there is no issue on anything, it's just a password changes. So to change your one small password, you have to follow your entire life cycle to deployment, and it's really painful, and this is not an easy task. It will take 1 week to 2 weeks, depends upon your business approval. Okay. So this kinds of changes, if you want to do any changes on your port, right, into the monolithic architecture, so you have to follow the same life cycle till deployment. So it's very painful when you don't have much code to deploy into the production in monolithic architecture. But in microservice, what they're telling is let's not do all those things. Okay, let's have all the configuration related things, like configuration what we have, all the port, all the application name means app name, some db password, some static thing that we are keeping into the properties file. So microservice architecture telling let's have your all configuration like properties or XML into the one place. Okay, let's put all those things into the Git repository. Name that repository is config repository, means it has all your configuration related things. Okay, good. Now what will happen is there are some API which is given by Spring Boot called Spring Cloud Bus. Okay, so if you want to change something, you just has to get the help from the Spring Cloud Bus, and there is no deployment required. There is no manual or no automation deployment required. You just have to hit the some services. So there are some service means your application URL slash bus and slash refresh, and another service also supported that called the application URL slash actuator and slash bus hyphen refresh. So these are all the custom predefined services given by the Spring Boot or Spring Cloud Bus to handle these kinds of configuration management. We will understand these are all into the coding perspective. Since this is the theory part, so I am going to tell you without showing the output here. Okay, so configuration means this kinds of a small deployment is very easy to deploy into the production, just matter of 1 second to hit the one service through your postman. Okay, so this is all about your configuration management, how we are doing into the microservice. Now next one is the naming server. This one is very important concept and you have to understand very clearly. Suppose that you will be having three services, service 1, service 2, service 3, and each services have some different port. Okay, everything is fine till now. You have to main focus on this area. Okay, so naming server is the centralized place where your all the microservice is registered. Okay, this is also called the Eureka naming servers, EUREKA, Eureka naming servers. So this Eureka naming server or naming server is the place where your all the service means service 1, service 2 are registers. Now what do you mean by registers? So naming server has the information that your service 1 having how many instance, service 2 having how many instance, even service 3 having how many instance. Since service 1, service 2 and service 3 having many instance, so it has the information also that the each instance running on which port, means instance 1 running on 8000, instance 2 running on 7000 port, instance 3 running on 6000. So for entire services that you are going to use into your microservice architecture have all the information registered into your naming server, and that we are going to achieve through Eureka. Okay, so this is the basically the centralized place Eureka naming server. This is in localhost /8761 is the by default port for the Eureka naming server. And if you see here, these are all the services, 1 service, 2 service, 3 service, 4 service, 5 services. These are all 5 services running. And if you see for this second services having 2 instance, you are seeing here 2, right? 2 instance means this service, this is my PC name, home PC running on 8001 and 8000. So like that, these have all the services information. If any of the service is down, if you see here status is up, means if any of the service is down, you will be getting the here down. So from this place means Eureka naming server is the place, centralized place from where you can keep the eye on your entire microservice architecture. Status of your microservice architecture means which service is up, which service is down, for which service what are the instance, how many instance, what are the port got used, all the entire information you having available here into your naming server. Okay, good. Now another important concept is the load balancing in microservice architecture. See, load balancing is the nothing new. It's very old. In monolithic architecture, we are also using very frequently. But the only terminology is new in microservice architecture is there are n number of services, and for each services we have multiple instance. So in that way, how we are going to use the load balancing? Suppose that any request came for the service 1 and service 1 have the 3 instance, okay, 8,000, 6,000 and 7,000. So once one service came and it start hitting the 8,000. So another request also came, it also hit the 8,000. So for 8,000 load is very high rather than 6,000 and 7,000. If you see live example in Amazon, like in December 25th December, your Amazon service will be very high, load will be very high, or any of the offer kinds of day, Amazon service loading is very high. So in that way, they will create the many instance of each and every service, means order, product, and many things like payment, all those things. So they will increase the number of instance. So how we are going to achieve this load balancing here? In general way, monolithic way, we will be writing some customized code or some algorithm to distribute the load from one instance to other instance. But here we need not to write much coding. That is handled by the Ribbon API, that is also given by the Netflix. Okay, so Ribbon API will help you to distribute your load from one instance to another instance or one server to another server. Since your service 1, service 2 and service 3 is already registered with the naming server, and Ribbon API will come exactly middle of the naming server and your microservice services. Okay, so these three will have the heartbeat communication. Okay, as I told you already here, Eureka naming server, how this server is going to understand this service is up or this service is down. So this is just because of naming server is always communicate with your each and every services called this terminology called heartbeat message. Naming server will send one message to your microservice, and microservice has to respond that message into this certain time. So the two-way communication happen. Then naming server got to know, okay, this service is alive and this service is down. So naming server and all your microservice communication is happening through your heartbeat message. That is perfectly fine. Now for the load balancing, there is another API which is coming in between, is called Ribbon API. Okay, Ribbon API, suppose that any service will come, any user will come, they first ask the naming server that, okay, I need the response for this request. Now naming server has the responsibility to redirect the request to the respective services. Suppose that naming server got one request called add, and add is handled by the service 1, right? And service 1 has the 3 instances, 8,000, 6,000 and 7,000. Now naming server has to decide, okay, this request where should has to go, 8,000 or 6,000 or 7,000. Assume that naming server redirect this request to 8,000. So again, if same request came, then naming server will going to decide whether this request has to redirect to the 6,000 or 7,000, and this is totally unpredictable where these requests are going. Only predictable thing is that one instance shouldn't have the much load. So all the instance having the equal load. That is only called the load balancing, and that is handled by the Ribbon API. We are going to understand in code perspective also very soon load balancing. Now another most important concept is called API gateway. Okay, so API gateway will help you to filter your request. Suppose that you will be having some REST call, right? And that obviously we will be having some authentication and authorization. So that will help you to not call service from the outside, or any authorized person should not has to call. That is perfectly fine. But API gateway is also giving you the much flexibility into the microservice architecture. So suppose that you have different browser means your client, okay, and this is, it has some request and it is expecting some response from the microservice. This Mozilla also having some request and this is expecting some response from your microservice architecture as well as Safari also. So these all three are the client. So my API gateway is the gateway means obviously is the English word. You have to understand very clearly that gateway means everything has to come in from this way and out from this way only. Now from if any request coming from this browser or this browser or this browser has to come from API gateway, and from API gateway this request has to go to the naming server, and naming server has to decide which service has to or which microservice has to get call for this request, and if is there any load balancing thing that has to taken care by the ribbon API. Okay. Now question is why API gateway is mandatory. See, suppose that there are, if you want to do the any business validation, you right away you have to do into the your API gateway itself rather than coming into the your actual services. See, API gateway is also microservices. That's why if you see this arrow, this API gateway is also registered with your naming server as well as your microservice also. So naming server has the information of your API gateway as well as your microservice architecture. This is the first thing. Second thing is that suppose that you will be having one business requirement that you are going to the visa company. You need some payment gateway, okay, payment API, and for that you are going to one visa company. Visa, you know, right? He already have some payment gateway. So visa company offered you, okay, I will be having some three kinds of services. Every day if you pay me $100, I will allow you to hit my API gateway 100 times a day. If you pay me 200, I will allow you to hit my payment gateway 200 per day. If you will pay me 1000 per month, so I will allow to hit my gateway however you want, n number of time in a day. So in this business, if you understand that everything is validation on number of hit on API, okay. So this kinds of restriction you have to write here, means for if any request come from this vendor, so the first filter will happen here, okay, this request is eligible for as per our business or not. If you got a for $100 per day, so per day means $100 100 hit, so it got validated here. $200 200 hit, this also got validated here. If it is not right, that immediately that response should go from here itself. This should not come to the naming server, should not come here and here. So there are many security related validation also that you can achieve into the API gateway. Apart from that, there are many things that we will discuss into the upcoming video, which is basically on hands-on. This is theoretical part. So these are all things you have to filter into the API gateway. Okay, so that is the reason API gateway is important for the microservice architecture. Okay, and this is basically achieved by the Joule. This is also provided by the Netflix only. Netflix happen Joule. Okay. Now next is the server unique identification. Okay, suppose that as I already told you, you got a Visa API. Now we again purchased a Flipkart payment gateway or some other MasterCard payment gateway. So how we are going to know that this request coming for the MasterCard or this request coming for the Visa or this request coming for the Flipkart? So there should be some identification number. So that is the will help you to understand the uniqueness of the each and every request and the response, and that basically we are going to achieve through the one Spring Cloud called Cloud Sleuth, SLEUTH, and for the form XML is that Spring Cloud Starter Sleuth. That also we will discuss into the upcoming slide. Okay, so this is all about your service uniqueness identification. Now is the distributed tracing. See, now we understand that we will be having many microservices which is running on the different services, different instance. So in that way, if there is any issue came into the production or QA or UAT environment, it's very difficult to identify through the log from where this request is coming, even though since everything is running on different independently. So there should be some centralized place from where we can get all the logs. So that is only called the distributed tracing, and that basically we are achieving through the Zipkin API. Zipkin API will give you this UI. Okay, if you see here, Zipkin API will give you this UI to trace your all the microservices log into the one place. If you want to use some ELK Elasticsearch also, you are free to use. Okay, so this is all about your log tracing, which is also called the distributed tracing. Fault tolerance. Fault tolerance means it's mock data. Suppose that you are going to hit one services and that services is down for some reason. Okay, suppose that that services is down for some reason, and in that way it will give you some weird exception or weird message to the client which is sitting on your UI. Okay, which have only UI view. So not to have this kinds of message or this kinds of UI, you should be having some mock data. Suppose that you are doing some get operation, you are sending one as a ID and you are expecting some output, and that output is not coming because of your server is down, and for that you have to send some data to the UI, otherwise UI will show some 404, some 500 or some weird exception. So what they are telling is fault tolerance means you have to give some mock data, however that is not benefit for him, but at least screen should not looks bad. So that fault tolerance we are going to achieve through the API called Hitrix. Okay, so this is all about the microservice architecture, very high level. We will be having some upcoming video, there we will be having some business rule. Over the business rule we are going to achieve all the things through our coding, but before that we have to learn the Spring Boot also. So and Spring Boot video is also upcoming. So let us know your comment, okay, about this video and what would be my next video. Accordingly we will plan. Okay, yeah, thanks for watching this video.